All right, kids. Um, Today I'm going to talk to you about arc lengths and areas of sectors. Okay, and the first thing I want to do is I want to talk to you about the essential question: what is a sector? Okay, so question: what is a sector of a circle in the first place? Well, I'll tell you what. The answer to that is the sector of a circle is created by two radii and their intercepted arc. It kind of looks like a slice of pizza. And there's something about the sector that I want you to know. So I think there's no better way to demonstrate this than draw a picture. Okay, here goes my artwork, so forgive me from now. So here's your circle. This is the center of the circle, and this is a radius. That is another radius. So what happens is, I'm going to call this point C for the center, I'm going to call this point A, and I'm going to call this point B. And whenever you have a radius and another radius, it creates what they call a central angle. The central angle is created by two radiuses and radii, and where the vertex is at the center of the circle. Okay. What happens is you've created this, looks like a slice of pizza, and that slice of pizza right here is called a sector of a circle. At the same time, these two radii intersect the circle at point A and point B, and they also create an arc, and this is called the minor arc. And the name of the minor arc is arc AB, and it looks like AB with an arc over it. Now, the reason that's the minor arc is because from A to B, the long way is the major arc. And usually you'll have a point somewhere along that circle, maybe 2 points or 3 points. I'll just call this point D. So the major arc, you know how minor means small and major means like big? So the major arc is going to be named A, D, B with an arc over it. And the thing that these two arcs have in common is they both start at A and end at B. So the minor arc starts at A and ends at B, but it's the small arc. The major arc starts at A and ends at B, but it goes through point D, which indicates that it is the major arc. So the minor arc is less than the smaller arc, and the major arc is the big arc for now. And then the way we notate that is we put the D in between the point D in between the A and the B, which indicates it starts at A, it goes in the direction of D, and it ends up at B. That's the major arc. So also, the central angle we're going to call, which is right here, we're going to call that theta from now on. And for the purpose of this section, we're going to use theta to represent the measure of the central angle in degrees. Okay, so that's all I could think of for now. I just want you to know that this is an example of a central angle. due to the fact that the angle is created by the two radii and they intersect each other at the center of the circle. So it's a central angle. Yay. All right. So our first objective number 1. Objective 1. In student-friendly language, I can find the area of a sector. So I'm going to just show you one way of finding the area of a sector, but then along the way I want to give you, I would love to be able to give you a reason why the formula is what it is, but here's an example. I'll teach by way of example. Just to make this to the point, example. So if I give you a circle, all right, that's my version of a circle, with a central angle, and supposing I tell you the measure of that central angle is 40 degrees. And supposing I tell you that the that the radius is 10, let's say 10 feet. And I said, find the area of the sector. Well, here are the steps. The first step I do is I recognize what theta is going to be. Theta is the measure of the central angle in degrees. I'm just writing this down so we know. And the radius. The radius is 10 feet. I'd like to establish my values. Then I write the formula. So I'll put step 1. Right? The formula. So the formula for the area of a sector is nothing more than this. The area of a sector is nothing more than theta over 360 times pi r squared. I'm going to give you the explanation for why that is the way it is. But first, I need you to be able to find the area of a sector in the first place. So step 2, my favorite part, we're going to make the substitution. So this is the substitution step. So when you're substituting, you're going to get area of the sector, which is theta. Remember, theta represents the measure of the central angle in degrees, and the measure of that central angle is 40. So we're going to put 40 over 360 times pi times the radius squared, which is 10 squared. And of course, check my substitution. My radius is 10. Yep. And my theta is 40. Okay, in the last step, calculator work. So you grab your calculator and just put the values in practically verbatim. You're going to put 40. Don't forget that ABC button right there. When you hit the ABC button, it's now asking you for the denominator, so we put 360. And we're going to multiply that. Remember, when we multiply by pi, we're using the pi button only, not the 3.14 unless they ask you. We always use the pi button. Then we multiply by 10 squared. So we put times. We're going to press in the 10, but you have to hit x squared because notice the 10 is squared, so we hit the x squared button right there. That's 10 squared. Now to execute all these multiplications, we have to hit equals, and we get our final answer. And if we round that to the nearest tenth, that's going to be, let me just double check my work, 40 ABC 360 times pi times 10 squared equals, and I'm getting 34.9. And that is the area. And there's the bell. So let me pause this. Okay, I'm back after all day long being gone. Let's finish Let's finish the next objective, objective number 2. In student-friendly language, I can find the arc length. I can find arc length. And it goes a little something like this. We're going to use the example from the same problem we just did, but now we're going to find the arc length. In other words, if I called this point A and I called this point B right here, and I said, let's find the length of arc AB. It might say something like, find the length of arc AB. So the first thing we do is we start off with a formula. So I'm going to use the letter S to represent arc length. And the formula for the arc length is theta divided by 360 times 2 times pi times the radius, not squared. Remember, theta equals the measure of the central angle. Again, theta equals the measure of the central angle. And that's going to be in degrees. Okay. So in order to get credit on this assignment, here's the steps you got to follow. 1, write the formula. For each problem, you're going to write the formula. And so that would look like this. Arc length equals theta over 360 times 2 times pi times the radius. All right, cool. Now, we're going to make step 2, we're going to make the substitution. So I'll just put substitute. When I say substitute, remember, if you look at the circle, the radius is still 10 feet, and theta is still 40 degrees, the measure of that central angle. Right there, right there. So I substitute properly. It goes arc length equals 40 over 360 times 2 times pi times the radius, which of course is 10. Now please don't do any arithmetic. This is all calculator work. So you're going to grab your calculator. Somebody took my calculator. So we grab the calculator. And as you know, we're going to start with 40, hit the ABC button, put in the 360. Now we're going to multiply that times 2 by 2, so we go times 2. Now we've got to multiply by pi, so we go times and we hit the pi button. Then finally we multiply by 10. You have to press equals. So we are getting an arc length to equal 6.98. And we're done. And that's feet, by the way. So the third step was to do the calculation. And honestly, we don't have to do any arithmetic whatsoever, because we're using the calculator. Okay. So I did give an assignment. I did give some problems to do. And maybe I'll do one with you right now just to reinforce what we just went over and get you going. So here we go. The first problem that we had was this, number 1. On the paper, they gave you a circle. They put the center of the circle. They drew two radii. The central angle was 87 degrees, and the radius was 40. We called that point L, we called that point M, we called that point N. And we were asked to find the arc length and the area of the shaded region. So I'm shading that in region, in which happens to be the sector. All right, so I'll start with finding the area. So in order to get credit for this assignment, you had to do this in 3 steps. Step 1, show a formula. And I'm hoping that you showed a formula. So the formula for the area of a sector equaled theta over 360 times pi times r squared. That is the formula for the area of a sector. And we just look at the circle and we see that theta is clearly 87 degrees. It's the measure of their central angle in degrees. And the radius is clearly 40. That could be feet, inches, miles. So I showed the formula for the area of the sector. Then I show a substitution. So I say area equals theta over 360. Well, theta is 87. We're talking about 87 degrees over 360 degrees. Now, multiply it by pi and make that other substitution for the radius. That's going to be 40, but what do you do to the 40? According to the formula, it's asking for an exponent of 2. Then once you get to that point, don't do any more arithmetic. Use that calculator. Can you grab that calculator? You're going to hit. We're going to do 87, ABC 360. We're going to multiply that by the pi button. And we're going to multiply that by 40, but before we hit equals, we have to square. So hit the x squared button right there. Now, some people were getting 1600 as the answer because they forgot to press equals. You got to press equals. Now, so you could leave that like 1214.7, and that would be appropriate. So the area of that sector will be 1214.7. Finished. Found the area. So notice I showed the formula, I showed the substitution, and I did the proper calculator work. Now for the arc length, again you have to do the same thing. You're going to say, okay, what's the formula for arc length? And we'd say S for arc length equals, again, theta over 360 times the circumference of a circle, which is 2 times pi times the radius. So we have our formula. Now let's make our substitution. So S equals theta, which is 87 over 360 times 2 times pi times the radius, which is still 40. And yes, there's a times in between there. So we're going to take that calculator again, and we're going to do the 87 ABC 360 Then we're going to multiply it by 2. Then we're going to multiply it by, you have to hit times and hit the pi. Then we're going to multiply it again times 40. Press equals, and we get our area of that sector to equal, the arc length. This is the arc length. And we find the arc length to be 60.7. End of story, and that was number 1. So notice what I did to get my answers. To find the arc, the area of the sector, I used the area of the sector formula, substituted, got my answer. To find the arc length, I used the arc length formula, made my substitution, and I got my answer. And that is the expectation. So good luck, and bring your work in completed, and I'll give you a full credit. And I really appreciate you kids, and I wish you the best. We'll see you tomorrow. Thank you again.